4. The nicotine content of a brand of cigarette is normally distributed with a mean of 14.5 milligrams and a standard deviation of 1.2 milligrams. So let's draw our little graph or our number line. 14.5, add 1.2 and you get 15.7. Add 1.2 and you get 16.9. Add 1.2 and I think you get 18.1. Then subtract 1.2, you get 13.3, yes? 11.1, 12.1, and 10.9. Excellent. So that is your mean plus 1, 2, 3 and your mean minus 1, 2, 3 standard deviations. What percentage of the nicotine contents are between 13.3 and 15.7? Oh, this one's nice and easy. Got it? That's between minus 1 to plus 1 standard deviations. That's straight from the textbook. 68. Okay? Girls, there is some mistakes here. This should be 78.50. Now, this is tricky. I actually haven't seen a HSC question like this, but it's really good because you sort of got to work backwards. Again, if you draw your number line with your mean in the middle, so the expected life of light globes is normally distributed with a mean of 8,000 hours. Now, that's mean plus 1, mean plus 2, mean plus 3, minus 1, minus 2, and minus 3. So I'm going to go mean plus 1, plus 2, plus 3 standard deviations, minus 1, minus 2, and minus 3 standard deviations. Now the question is, now this is working backwards, this question. What is the standard deviation if 95% of the globes are expected to last between 7,700 and 8,300 hours? Now 95%, is that, remember the three numbers, 68%, 95%, 99.7%, isn't 95% between minus 2 standard deviations to plus 2 standard deviations from the mean? That's 95%. So I can put, what values do I write on my axis? What is the standard deviation if 95% of the globes are expected to last between 7,700 and 8,300 hours? So this is 7,700 and this is 8,300. Now, it's a number line with equal gaps between them. If from 800 to 8,300 represents 2 jumps, which is 300, how much is one jump on the number line? It's 150. Each jump, if from there to there, you know how we go plus 2, plus 2, plus 2? If the standard deviation was 2, wouldn't you go plus 2, plus 2, plus 2? Well, plus what gives you a jump of 300. I've got 2 jumps. I added something and I added something and I got 300 more. So now what do? 300 divided by 2. Each jump is 150. Do we get that? So that means that is the standard deviation. So the standard deviation is 8,300 minus 8,000 divided by 2. It's the jump of 300 divided by 2, which is 150. Now, but my figure here is 8,150. You get it? See, because I jumped 150 and I jumped 150. Do you get it? All right, now I don't really want to put those there because you're going to think they're percentages and they're not. Remember how I start my graph normally? I put my mean, I add my standard deviation, I write it there. I add another standard deviation, I write the answer there. So these have to be 150, so this is 7850. And then that's good, 7,700 works. Can I have these last ones too? This would be 8450, wouldn't it? And this would be 7550. So I've got all my numbers in there. So the standard deviation is 150. Part B. Between what two values does 68% of the lifetimes lie? Isn't 68% between plus 1 and minus 1 standard deviation? So what two values? We've already filled them in. See how this timeline is, not timeline, but this number line is really good? Gives you all the answers. 68% is between which two values, ladies? 7850. So 68% lie between 7850 and 8,150 hours. Now, there is a mistake in the textbook. It's put the answer for some other question. It doesn't have that, okay? And part C says, if 12,000 light globes are produced. Now remember that 12,000 light globes is everything, the 100%. How many are expected? How many are expected to last less than 7,850 hours? Now, how many? Don't worry about how many. What percentage are going to last less than 7,850? If I want less than 7,850, I need to know from here down. Okay? I need to know from there down. Now, I don't know from there down. I know from halfway down. What's halfway down? Here's another highlighter up here. What's half of the graph down? So half of the graph down is 50%. So I just need to know this bit, don't I? So if I want, yeah. So if I know that half the graph down is 50%, that bit, do you get that? And I want this bit down, I just need to know this bit. Do you get it? I know half of the graph down is 50%. I need to know this bit. This is my question, this bit. I need to know what this bit in here is. Now, isn't it half of 68? 34. So that bit there is 34. So this bit that I want is 50 minus 34, which is 16%. But, read the question. 16% will last less than 7,850 hours. 16% of what? 16% last less than 7,850 hours. 16% of what? 16% of the total. So if you want the number, how many, the number of globes, so the number of globes will be 16% of the 12,000. Do you get that? It's 16% of how many you've got. We've got 12,000. So 16% of 12,000, which is 1,920 globes. That's a really good question, that one.